afternoon. I'm not going to be one of these people who says you've made it to Friday, because that's not how I view the week. Every day is a brilliant day as far as I'm concerned. However, it is Friday and it is time to do some work on finding the area of a triangle using trigonometry. Now, if you've never done anything like this before, then maybe make sure you understand what trigonometry is. If you're watching this live, then brilliant, it's lovely to see you. If you're not watching it live, that's also lovely to see you, but I'm not actually seeing you because you're here and I'm not here anymore, because I recorded this now, but this now is not your now. Your now. Let's forget all about that because it's going to go on forever. Okay, I'm going to go straight into the introduction and then we're going to go straight into my whiteboard where I'm going to try and explain all the 3 different permutations of this problem and make you strong like a bull, where you can make sure you can do all these problems. So, these problems today are all going to revolve around dealing with triangles that are not necessarily right angled, because right angled triangles are more complicated. So we are going to be dealing with triangles which are just irregular. And what we're given is always going to be an angle such as 62 degrees and 2 included sides, 7 centimetres, and in this one 9.4 centimetres, because they do not have to be whole numbers. Now, we have been given them. Now, obviously, this could well be that we are given in a question X centimetres, and we have to work this out, but we're given the area. We're going to deal with that later. For now, we're going to stick to a problem where we're asked, what is the area? Now, way back, many centuries ago, when you were doing in year 6, and you were finding the area of a triangle, you just did base times height. You just got your triangle, and then the teacher came along and said, excuse me, should you be doing something with that base times height? And you went, I can't remember. And you're like, yes, we're supposed to halve it. We had to do base times height and halve it. However, we are now GCSE students, which means we need to learn that also, when angles are involved, the formula we need is half AB sine C, where we choose the letters. Now, it can be that the letters are given to us in the question. We'll do one like that in a minute. But the area equals half AB sine C. It is up to us to label. C is the angle, and A and B are the 2 little sides either side. Worth noting, the side opposite the big C is little c, but we don't need that for this problem. So I'm going to put a cross through it. So we've got A and B. So now it's just a case of putting numbers into this formula. This formula is one you need to learn. It's half AB sine C. It is a formula you need to know, and it is then easy for us, hopefully, to plop numbers in it. Half times 7 times 9.4 times sin 62. That is all we're doing, is taking these numbers and putting them in the formula. Notice, to do this, we need the angle and the 2 sides either side of it. That will only work if we have the 2 sides either side of the one angle. Then our calculator delivers, as long as it's in degrees mode, and there's been a couple of my students who accidentally, maybe it's been in their bag and buttons have been pressed, you have to make sure it's in degrees mode, which is done by shift, set up, and then click 3 for degrees on my calculator. Everyone's is different. I am going to do half. 0.5 does count. Student called Bobby of mine was just wanting to check that. Absolutely sensible thing to clarify. But since that half and 0.5 are the same, we can interchange them. And my calculator tells me that this is 29.04897581. But we don't want to write it that big. So it will normally tell us in the question to 1 dp or give us something. So we're then going to write 29.0 to 1 dp to say that we've rounded it. And then we're going to write centimetres squared because it's an area. Remember, we're finding an area, so it's going to be centimetres squared. Now, when we're doing questions like this, it's really important you lay out your working. I would never want to see any student who's learnt under the tutelage of Mr. Harris just writing 29.0, that's the only thing they write on the page. I would want to see the formula, I'd want to see the first line of substitution, then the full answer, and then the rounded answer. You Can't go wrong if you do that. Full marks when you get to an assessment. Now, the second round of things, and I'm just aware, I meant to put a worksheet in the description below. There will be, by the time you're watching this, unless you're watching live, in which case it's not there yet, there will be a link in the description to a worksheet for at the end of this lesson, so you're going to be able to go away and practice this skill. But I did promise, what would I do if it's given me letters? Well, we don't panic. We go, okay, here's my new triangle, dooby-dooby-doo. Obviously, whenever you draw triangles, you have to say dooby-dooby-doo. And this one has got C, D, E. Which means, when I've got my angles, I'm going to give you 73 degrees, and I'm going to give you 8.6 centimetres and 4.3 centimetres. And it says, what's the area to 1 dp? So what we're going to do is we're going to use the formula, but this time, when we work out this ABC, we need to appreciate, in this sense, the little letters are E, C, and they're always opposite the capital letters. The capital letters is the angle, the small letters is the side. So therefore, that is why the formula here would be half CE sine D. It's the two little letters sine the big letter, and that's the angle. So it's going to be equals half times 8.6 times 4.3 times sine 73. Plug it into my calculator, I get half times 8.6, half times 8.6, 4.3, sine 73. And once we've done that, we press equals, and hopefully your one doesn't have, you don't press the times button twice, because that's what broke it in mine, and I get 17.68, which is 0.7. We want to round it. I'm going to write 682 with a dot dot dot. That means it's not rounded yet, then my rounded answer, just so you can see the difference. Dot dot D means I have done no rounding. I've just written the first three digits, and then I've done rounding here, so that's where I've got 17.7. This is going to be centimetres squared because it is an area. But the reason I use the formula changes depending on what letters you've got. It's always, however, the angle and the two sides either side. That means you've got the scope for slight messing around, because someone could come along and go, I'm going to catch this person out. Could you have 21 centimetres there and 73 centimetres here? Not 73, that's a weird number. 17 centimetres here, and we'll have that angle is 42 degrees, and that angle is 16 degree, is 51 degrees, and you go, okay, wait a minute. To find the area, I need two sides, but the angle has to be the one that's between them. But what we can do is go, wait a minute, this must add up to 180. These two must add together to make 180 with this one, which tells us we've got 93 there, is 87 missing. Then we can do the area rule. Area equals half AB sine C. Big C, it hasn't got letters, so we're going to have big C, A, B. It doesn't matter which way around you put A and B, by the way. Half times 17 times 21 times sin 87. And then we put all the numbers in. We've got 17 and 21 and sin 87. I can tell you sin 87 is quite big. So it's going to be 128 area. 128.255 dot 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 hasn't been rounded. We want to round it to one decimal place. 178.3 centimetres squared to 1 dp. So here you can see they're the main find the area. However, the second half of this video is going to be talking about what if they've given you a question, and I keep saying this, they, who are they? You know, the secret society of question writers. You know, you in exams, they're all written by this secret society of question writers. No one knows who they are. They clearly haven't got any people that we would ever know there, but they must have friends and family. Anyway, here is the sort of question I'm talking about. What do I do when this occurs? Here's my triangle, everything's going well. Here's my angle, everything's still going well. I've got 7 centimetres, we're super happy, and it then says 8 centimetres, and it then says the area equals 43 centimetres squared. And you go, oh, this is not right. Sorry, we don't see that. We have X centimetres, and the area is 43 centimetres squared. And we're like, oh, whoa, 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 don't like this. Do not like this because it's backwards. We don't panic. We first of all go, we need a side, and an angle that's between them. So that's fine. We're going to call that A, B, and C. We're going to fill out our formula. Area equals half AB sine C. But this time, when we put our things in, we're going to put a 43 in there equals half times 7 times x times sin 82. And this is the tricksy bit. When you want to get things onto get the x on its own, we're now going to have to do some division. I am going to divide 43, divide by half of 7 is 3.5, so 3.5 sin 82. All I've done here is I've taken, and I'm going to change the colour so you can see exactly what I'm talking about. I've taken half of 7, that's not a nice colour to use on the screen. I've taken the half of 7 bit, was the 3.5, and I've taken the sin 82 and divided by them, so they've both gone to the bottom, which should just mean equals x. X is now left on its own. So we use our calculator, 43 divided by 3.5 sin 82 is 12.4. And that tells us that it's 12.4 centimetres. This time, remember, it's finding a side. So this means that we're not going to be stumped on a question where we're given the area and we have to find a side. But then I hear some people cry, but sir, wait, you've still got a problem. And I say, I know, but it's not to do with maths. And they say, no, okay, maybe it's not. Here is the final time we might have an issue. This time, we're super happy. We're minding our own business. 8 centimetres, 10 centimetres, everyone's happy. Weird squiggly symbol. Area equals 60 centimetres squared. What? It's given us the answer and we haven't got the angle. We don't panic. We put everything in as normal. We've got our capital C, our A, and our little b. So we write it out the formula. Notice how I write the formula every time. If I don't cut shortcuts, if I don't cut corners, you don't need to. I wouldn't do it any extra working than I needed to. The area we're told is 60. Is half times 8 times 10 times sine C. This time we want to get on its own sin C, because that's the unknown so far. But in fact, I'm even going to change it from C to theta, because that's the angle we're trying to find out. Now, what we therefore do is we do our same thing as before, but I'm going to do a little calculation first. I'm going to get this. Half of 8 is 4, times 10 is 40. I therefore have 60 over 40 is sine C, and sine theta, and this is the bit that some of my students forgot. To undo sin, it's not a divide, it's not a times, it is a special operation called sine to the minus 1, which is found by getting, of your answer, by getting shift on your calculator before you press sine. Shift, then sine, gets you sin to the minus 1. And if I do shift sine, sin to the minus 1 of 60 over 40, it'll undo it, and it's a maths error. Oh dear. I must have produced a question that doesn't work. That's my fault, but I can resurrect this by realising that I needed it to be bigger than 60, so the area, let's change the question, because when I'm trying to teach you this sort of stuff, I think it's always useful to have an answer that works. Imagine I'd said the answer to the question was actually 30. Put those numbers in, and it's almost like they were never there. Don't know what you're talking about, 60. I said 30 from the start, didn't I? So then we've got 30 divided by 40. So we do that divided by, so sin to the minus 1 of 30 over 40. And you get the answer, theta equals 48.6 degrees, because it's now a degrees, we're finding an angle. So these two ones are the special ways of doing it when you've got working backwards solution. We have to do 30 divided by 40, sin to the minus 1, and it gives you 48.6 on our calculator. So what I'm going to do is I'm going to leave it there. I'm going to go straight in and make sure that the link in the description works, so you can then use the link to do some practice questions like this, and there's questions that are all these sorts of things. Hopefully this video has been useful. I'm certainly going to be directing my year 10s who need revision of this to go and watch this rather than just asking me first. Hopefully that's useful. I will be doing another video next week on the cosine rule. So on Wednesday next week, a video will come live on the cosine rule. Hopefully that's useful. I've been Mr. Harris. You haven't. Look after yourselves. Take care. And I will see you soon.